Yeah, so we planned on this session because of high voltage AC compressor become more relevant in our industry, especially with hybrids and electric vehicles. And with the season coming on with air conditioning, there's still a lot of mystery about high voltage AC compressors. So today what we promise you is we're actually going to tear down a high voltage AC compressor, describe some of the components inside the compressor, how it works, some of the cool strategies that they do use in these compressors, which makes them very unique, as well as we're going to do some testing as well too, to show you some of the maintenance and the testability of these compressors. But also we're not going to forget about safety. So one of the things I want to demonstrate is when you're testing these components, even as we power down the system, and I do have a vehicle in front of me, which you'll see in a second, even when I power down the vehicle, you're going to still see that you have to be aware of what you're doing and how you do it, and I'm going to show that with the high voltage AC compressor. So today's session, we're going to talk about construction, components, functionalities, operations, and testing. So right now I have one of our EV400s here representing a full electric vehicle, operational. And what I want to do is I just want to go through the sequence of a faulted AC compressor real quick. I just want to do it here on an actual trainer, apply it to the vehicle, then do a tear down on the compressor. So what I've done is I put the key fob in, and essentially I can turn on the ignition here. So I have the ignition turning on with the vehicle. Oops, did I get it in there? Yeah, flip it around. Here we go. Okay, so I have ignition on. So just like a regular electric vehicle, I'm going to push the brake pedal, and I'm going to hit the ignition again. We're going to see our charge contactors come on. Then we see our contactors turn on, which now we have high voltage in the system here. So currently, right now, we have a fault set for the air conditioning compressor down here. So I'll show you what happens. We're here. We're basically going to operate the vehicle. We're going to go for a drive. There's no issues right now because we haven't told the power control unit to send power to that AC compressor. It's not requesting it. Problem in the stator with this one. So even as I'm driving the vehicle down the road and I turn on the air conditioning, I have now an isolation fault. There's a faulted system. Vehicle basically goes into a default mode, pull over the side of the road. Now we have a situation where we have a faulted high voltage component that needs to be diagnosed. So let's just go to the vehicle. I want to start taking a look at the actual compressor. We'll do some testing there. Then we're going to get inside this AC compressor. So what we're doing is we're just going to move the camera over to the car. And as we're doing that, I have a few things set up here. So we're going to be looking at the a milliohm tester as well as an isolation tester here with the unit itself. So I'm just going to get us cameraed in. I'm not the camera guy, so there we go. Thank you. So as you can see, I have disabled the high voltage system on this vehicle. I've done the procedure to do basically a service disconnect. I disconnect the negative terminal of the battery, and I just want to go through a real quick test with this vehicle. Now, I'm not going to go into the full diagnostics with this one here, but I do want to show something that's very important using when we have an isolation fault. What I've done is we do have a disconnected connector here, high voltage connector. We powered it down. We tested. There's no high voltage in the system. We tested the connector, no high voltage. But now we want to do an isolation test to it, find out where the fault may be, is it within the unit itself, and so on. There's lots of different specifications on testing high voltage compressors. Some of them are 250 volts, 500 volts, and so on. So what we're going to do is we're going to do a test to this compressor.
Dave, real quick, is there a way you can change the screen to full screen? And because right now it's really small in presenter view, and a lot of people are having trouble seeing.
Sure.
Sorry.
I got my magic guy there. That's great, because while he's doing that, I'm just going to get my gloves on, and I'm going to power the unit up. Oops. How's that, Jimmy?
I think that's better. Someone give me a thumbs up in chat if it's
okay. Great, excellent. So what I've done is I've set this, and I'm just doing this to emphasize the importance of when you're testing, you do it properly, and you ensure that there's no, you're not going to put yourself in a situation that could harm yourself even after doing testing. You got to remember, there's no voltage in these components. So if I go right now to my DC voltage on my meter here, now just to make sure, I'm going to take my meter leads here. I'm going to go 1 to 1 here, and I'm just going to touch inside here. And we can see we have no high voltage or any DC voltage there. So what I'm going to do now is I want to do an isolation test, hence the fault that we've shown on our trainer there. So I'm just going to do it to chassis of this because I could do it at the case of the compressor or so on. But I'm just going to do it to chassis here. But I just want to show what happens. So I'm going to set this to kilovolts. And as we do this, I'm on the kilovolt reading for the testing. And I'm just going to put the probe in to the connector, and I'm going to push test. So I'm going to put voltage into the AC compressor. Now I got to remember, I'm going through an inverter, so there is specifications on doing this type of testing. Maybe a little bit more involved. Sometimes we rely more on the codes themselves, but I can see I put it there. Now this is really important. Since there's an inverter controller inside this compressor, there is capacitors inside here. So if I just release this, some people think, okay, well, it failed. I'm going to go and now we're going to replace the compressor on this, not realizing they have just charged that compressor with energy. So what I'm going to do is I'm going to switch my meter over to DC voltage. I'm going to turn the screen on here, and I'm going to set my min-max on the screen here. I'm going to hit min-max here. So I got my max reading, and all I'm going to do is I'm just going to go to the connector here, and I'm going to touch it, and we're going to see that we have 129 volts stored in the capacitor on that unit. Now, mind you, it discharges extremely fast, especially if I leave my meter on it, because the impedance of the meter will draw down that voltage. But if you're not aware of that, you can wind up taking this apart and creating a small spark, getting a small shock, which could scare you. So it's important to make sure that you follow the procedure in how to do an isolation test when you're testing a high voltage component. So what we're going to do now is we're going to go back to our board here where we have a compressor we're going to tear down, and we're going to take a look at inside that compressor. Okay, so as we swing the camera back over, and Jerome is just getting set up there. There we go, great. So we already removed the bolts off. Obviously, we cleaned this compressor up. It's a high voltage compressor. So essentially, the unique thing you're going to see with the high voltage compressor, it has no belts. There's no drive belts on it because, once again, electric vehicles and so on, because of their design, when they come to a stop, they're not running. There's nothing to drive the belt. So obviously, we need to have that, as well as preconditioning. We talked about preconditioning. The cabin of the vehicle, cooling in the summertime, and so on. So it's like, so we want the compressor to run on the demands of the system, as well as there's lots of other systems that rely on the compressor, from your electronics to your battery, if it has thermal efficiency with a chiller, or thermal exchange with a chiller, and as well as your HVAC system. One thing I want to point out, though, is you're going to see we have the low side port here, and we have the high side discharge port. So one unique thing about a lot of these AC high voltage compressors that are electric, the low side is usually very close to the electronics in the unit itself. So you're going to take it the last 2 bolts here. And that's to keep the electronics cool. So there's a few things you're going to see very quickly with this, this unit here, is that you'll see the electronics here, the board. I'm going to go through some of the components here, but you can see also, if I remove this from the stator, you see that there's almost like a heat sink plate, but it runs right beside the low side port coming in, which would be very cold, carrying the heat from the evaporator. So one of the unique things you'll see in a lot of these AC compressors that are high voltage is the low side port is close to what we call the controller inverter, which controls this three-phase motor. As we continue to tear this down, I'm going to take off the end here, take off the last couple bolts. These are through bolts for the body. Now, the other thing about these compressors is I get asked this about AC components or high voltage components. This is actually an IP67 protected unit. So that means it is water ingestion protected, as well as dust and dirt protected as well, just like our high voltage batteries. So in the case here, I'm going to start pulling this guy apart. I'm going to pull off the end here. Oops, one more bolt here. So we're going to see here, let's get this guy out. There we go, we got the gasket and so on. So we can see here, we have the back here. Obviously, it's looking like a type of compressor that we're pretty familiar with. In most cases, is the scroll compressor. So it's a scroll style compressor. It's actually in 90-degree section. So it's a 4-stage, 4 pressure chambers. You can see the relief in 2 of them there on the outside. And then we have the center one, which is main discharge. And of course, as we go through the rotation, you get the primary charge or the primary pressure. And when the reason they do that is to smooth it out. So scroll compressors are typically a quiet, easily variable compressor, and also a very smooth, rather than a piston style or other types of style compressors that can be very noisy in the system. I'm going to take this and flip this one over. And inside here, we see that there's our counterweight, which actually there's another counterweight on the rotor itself. We'll see that in a second. We have our standard bushings on top here. They actually come out. You'll see them there. So our standard bushings that ride on the shaft that rotates that scroll. So as this thing turns here, we actually have rotation within the scroll, which actually operates it. So let's go back into the electronic side, because this is pretty standard. Is taking low pressure, making high pressure by superheating that refrigerant into high pressure before it goes into the condenser, whether it's inside or outside the vehicle, depending if it's a heat pump or not. And I'm just going to get these 2 guys apart here. Can get a little screwdriver maybe. Yeah. Do we have a little tapper? You got me a screwdriver, all right. Let's see if we can get in here a bit. Here we go. Okay. So now as I pull this apart, this is the thing that surprises most people, is that the actual intake port on this compressor is directly exposed to the stator itself. So the windings are actually exposed to the refrigerant and oil that goes through the compressor, that goes through the scroll to be discharged out the back of the compressor as high pressure gas. So this one here, the scroll itself is attached directly to a rotor, and here's our rotor here. And in fact, this compressor that doesn't have an isolation fault, as we described earlier, actually has a bearing fault in it. So that's why it was replaced. But it gives a great example of it. So here we go. We got a standard stator, and we have a permanent magnet rotor. The magnets have been removed, typical neodymium style magnets. You can see it's a 6 magnet rotor, and it's a 27 segment stator. So it's wound 27 times. Most stators are usually around about 18 times. And the reason for the extra holes, I guess you could say, inside the stator here is for harmonics. By having more, it smooths it out, less harmonics, less noise inside that compressor itself. So testability, it's still a 3-phase motor itself. So we have the 3 phases there, just like our drive unit in the back of the vehicle, but just a lot smaller, obviously. So now if I go back to our board here, we can see in the back of this board, I'm going to flip this around just so it gives a little bit better positioning, but we can see a few things. We have DC voltage coming in. We can have it labeled. That was actually done by the manufacturer, so that'd be a negative and positive. It'd be 400 volts going into this compressor. Then we have isolators here. basically these two guys will take away the DC current ripple that would be present on DC voltage, not AC voltage, DC voltage. And then we can see all the IGBTs. Now, if you remember, we had 27 segments, so essentially there's nine groupings for the three-phase. So we have 1, 2, 3, 4, 5, 6, which will pair up to make our stator, excite our stator to turn the rotor inside here. So once again, it's a very unique setup for this, but there's 3 for each phase. And in fact, we can see the controller side of here. So there's the 3 controllers, and as you can zoom in here, if we have a little screwdriver pen there, please, thank you. So I was trying to zoom in here, but you'll actually see on the board itself, you're going to see each of the legs here. So we see the WG IGBT1, 2, and 3, and they control our basically our MOSFETs or our IGBTs that operate the 3-phase through pulse width modulation. So these are very unique. In fact, it's funny with this one, it has W, V, and U as our positioning. So the other thing is too, the compressor itself is communication is done through CAN bus. So most compressors are like this. So we see our high and low CAN wires there, our blue and our yellow wire. And of course we have our positive and our ground. And the communication that the board will give us is mostly like temperature, RPM, pressure in some cases, temperature, in some cases, so it gives me those pieces of information, as well as it will give me diagnostics as well too. So I can get diagnostics through the scan tool onboard computer to actually do that. Now, the other neat thing with this here is some of the things you're going to see are goo on here. You'll see a bunch of goo on here. You'll see a bunch of, goo here and so on. So anything that has goo on it are basically part of the high voltage part of this board. So they actually protect that board. But the board is not really super protected in the sense of, from heat and stuff like that. And that's why it refers to, like I talked about earlier, on the side of our intake side of our refrigerant coming in to cool this board itself. So we covered a lot of different information with this unit. And as you can see, there is actually capacitors inside the unit itself. And this one's actually cold soldered right to the board, or soldered right to there's another board underneath here. And that's why when we were testing with the vehicle, we were doing the isolation test, we had we had reserve energy after I did an isolation test, because I didn't let the capacitors discharge by using the proper function of that tool. And they're pretty much all the same. I have several different types of isolation testers there. So inside here, so we have our IGBTs that actually control our 3-phase. We have our control side, pulse width modulation on them. We have our high voltage components. We have our CAN bus system right here, CAN bus communication on here, and of course our electronics for our function and strategies and so on, part of the unit itself. Now, if I was going to test it, and this is also an important point, remember I was putting high voltage insulation test through this line that is actually goes through the back here, goes through the little screws here into the isolators, which goes into the board. So I'm not actually directly testing the stator windings in this unit itself. So unless there's a short to ground or case to ground, and I'm testing it through, the unit itself, it may be difficult to get a proper reading from it. And this is why a lot of manufacturers say, be aware, if you're going to do an isolation test, follow OEM procedures, because I shouldn't just throw 1,000 volts or even 2,000 volts in some cases for isolation checking through the unit, because I may be going directly through electronics to do that. So I could wind up damaging the electronics. At this point here, I could definitely do an isolation test to this unit from each of the legs of the stator, looking for which one is bad here. But obviously, we're not going to be tearing apart compressors and testing them directly at the stator. We'll rely on codes and OEM test procedures when we're testing these compressors for those types of faults. Okay, so one last thing I want to do is I just want to go back to the video. I know this is fast. We're just going through it. It's very quick, but we do have another video that's going to be coming up that's going to be more on the diagnostic side, talking about the different things that happens with these compressors. I already mentioned one was a bearing here, which is very common on some of these. But I do want to explain a little bit too. That's why it's so important to have the proper oils. And this is one point before I go back to the cars. The oil is critical because you got to remember the stator and the rotor are exposed to the oil and the refrigerant in the system. If you have the wrong oil, like a PEG oil, and some manufacturers claim that only 1% of PEG oil in the system can cause problems, which can cause isolation loss, which can cause failure, which is a big job if that happens. POE oils are designed, polyester oils are designed to coat and insulate as well as lubricate the compressor as well. So it's very important to have the proper type of oil. Always follow manufacturer recommendations. There is no such thing as universal oils in AC systems, whether it's a belt-driven compressor or an electric driven compressor. So I'm just going to do one more thing on the vehicle. Just kind of at the end of a repair, we're putting the compressor back on. And I just want to show a quick test before we let the vehicle go at a final stage. So what we've done is this is another test that's important because we have high voltage in the system and it's exposed to possibly the case of the vehicle or the chassis components. So what we want to do is we want to make sure it's properly grounded. All high voltage components should be properly grounded and properly checked as well. And one of the tools that does a very good job of it is our milliohm tester. It's a quick test that you can do. This one's a very inexpensive one. I usually put this one up here because I know cost is a big factor. So this one does the job. The big thing is that you have to manually zero it, but that's okay. So what I'm going to do is I put the one lead of my milliohm tester on the ground portion of the compressor, the ground strap portion of the compressor, and then I go to 2 points on the vehicle. I'm going to do from essentially the shock tower area to the crossbar. So I'm going to put this one on here so I get my reading. So 6.77. The manufacturers do have specifications we call exponential bond testing, usually done on high voltage batteries, but it also can be done on components as well. And once I have that, I stabilize the number, 6.6 milliohms, and then I can go to another component here, and I got about the same, probably less than about 2 milliohms or 0.2 milliohms. So well within specifications. Some manufacturers are 1 milliohm. So we're well within that spec. So as we finish the repair, we validate that we replace the compressor. We checked its isolation against the chassis through bond testing, and then we can proceed with finishing up the job by re-energizing the system and following those procedures. Anyways, if that's about what we have for today, if you have any questions.
Yeah, feel free to put your questions in the Q&A. It looks like the chat's actually open too. You can put them there. A reminder that this webinar and all of our previous ones can be found up on our YouTube channel, which is youtube.com/ConsolabOfficial. You'll find all the previous webinars, and then by Friday or so, tomorrow, this one will be up there live. And then I believe we're still giving out certificates of participation to go towards your PE hours for everybody who was in here. Our staff will reach out and get those to you in email. We've captured everybody who's been in here. We certainly appreciate everyone's time that they've given to us. And I know our two guys here went pretty deep on the subject that you probably haven't seen covered before. So I personally thought that was really cool. I got a couple texts from people who were watching. They said, Wow, this was an A+ one. So good job, Dave and Jerome. This
Yeah.
is the kind of information we like to provide to our customers. We'd like to be partners with you throughout the process from planning stage all the way through your entire program setup. And if you ever purchase trainers from us, of course, we're here to support you that way as well. Guys, it doesn't look like we have any other questions, and I'm just rambling at this point. So unless you have anything else to say, we'll bid adieu.
No, have a fantastic day, and always feel free to reach out to us for any questions or any comments that you may have.